You just finished a 14-hour liver transplant. It's 4 a.m. and you're ready to transport directly to the ICU. The OR nurse says, "The O2 tank doesn't have much left in it, but we should be okay." Let's talk real quick about some ways to determine if she's right or if you might run out of oxygen in the elevator on the way to the ICU. First off, some general properties of oxygen cylinders. They're green in color. A full tank contains 660 liters of gas, and a full cylinder has a pressure of 2200 psi. The volume of gas remaining in the tank is directly proportional to the pressure gauge reading. For example, if the gauge reads 300 psi, how many liters of gas remain? To determine this, you set up a simple equation. 660 liters over x equals 2200 psi over 300 psi. Solving for x reveals that when the pressure gauge reads 300 psi, there are approximately 90 liters of oxygen gas remaining in the cylinder. And if you were to transport using 10 liters per minute of fresh oxygen flow, you have approximately 9 minutes before you run out of oxygen. A simplified way to estimate this is to use a quick rule of thumb, taking the pressure gauge reading multiplied by 0.3. If you work the math, 300 psi times 0.3 equals 90 liters. Now let's transition to nitrous cylinders. Things are a little bit different in this regard. First off, nitrous cylinders are colored blue, and the physical state at room temperature is a combination of liquid and gas. A full cylinder contains approximately 1590 liters and has a pressure of 750 psi. As the tank is used, if liquid nitrous remains, the pressure will remain at 750 psi. If one really wants to know the volume of nitrous remaining at this point, you would need to weigh the tank. The weight of the tank in grams is then divided by 44 grams per mole to get the total number of moles of gas, and then converted to liters using Avogadro's number of 22.4 moles per liter of gas. Thankfully, we don't have to do this very often. Now, at the point where all of the liquid nitrous is gone and only gas remains, there's approximately 215 liters of gas in the tank at 750 psi. If you continue to use the tank, the pressure at this point will begin to drop. If you then take that volume and pressure, 215 liters with a psi of 750, as a starting point, you can then determine the volume remaining in a similar fashion to oxygen cylinders. For example, if the pressure gauge reads 300 psi, set up the equation of 215 liters over x equals 750 psi over 300 psi. Solving for x reveals an approximate 86 liters of nitrous remaining. Our quick rule of thumb also works with nitrous tanks. Again, take 300 psi, which is the pressure reading from the tank, times 0.3, which reveals approximately 90 liters. Close enough for government work.